there. Welcome back to FE Made Easy. Today I want to talk about some geotechnical engineering problems. Let's go ahead and do that. Convert a total mass density of 1900 kilograms over meters cubed to a total unit weight for use in stress calculations. So we are given a density of 1900 kilograms per meters cubed, and we have to transform it to a total unit weight. What does that mean? There is a relationship between the total unit weight and density, and the relationship is as follows. We have that total unit weight is equal to the density multiplied by acceleration of gravity. And this relationship is also given in the FE handbook. And let me see, I want to find it for you. Let's say I'm going to look for specific weight. So specific weight there you go. So here it is. So we know that specific weight or the unit weight gamma is equal to density multiplied by the acceleration of gravity g. Perfect. So now we know that. We can come back to our problem, and we have that density is 1900 kilograms per meters cubed. Now, how much is acceleration of gravity g? We are working in SE units, kilograms over meters cubed. So we're going to go back to FE handbook, and I'm going back to the unit section. And if you scroll down a bit, the second page, you're going to find here gravity acceleration, or acceleration of gravity, it's also called. And you have the value for metric units or USCS units. In our case, we have metric units, so G is going to be equal to 9.807 meters over seconds squared. So let's add this here. So G is 9.807 meters over seconds squared. So now we can come here and substitute in our problem. So total unit weight gamma, this guy, is equal to the density, which is 1900 kilograms over meters cubed, multiplied by G, which is 9.807 meters over seconds squared. And let's go ahead and use your calculators with me, please. And let's see, we're going to have 1900, 9.807 multiplied. So I get a number or a value of 18,633.3. And these are, so let's see, let's do this some reduction, meter with meter. I'm going to have kilograms divided by meters squared multiplied by seconds squared. Perfect. So now I'm looking here at the answers. I have to bring this unit here to kilonewtons over meters cubed. Let's see, how do we do that? Back to the FE handbook unit section, I know that 1 Newton over here is equal to kilograms multiplied by meters over seconds squared. So that's 1 Newton. So if I go back here, I have to bring this. So let me write this down. 1 Newton is equal to kilogram multiplied by meters over second square. And I have to bring meters in my case here at the top. So what I'm going to do, I'm going to multiply. Remember, if you multiply by meters cubed, in order to not to change anything, I have to divide by that at the same time. So right now I have not changed anything. So this is like multiplying with 1. So in this case, now I'm going to get rid of these meters at the bottom. And now I can rewrite this as 18,633.3. And now kilograms multiplied by meters over seconds squared. So I have kilograms multiplied by meters over seconds squared. This is equal to 1 Newton. So I have Newton over meters cubed. And this is my answer. I have to bring it to kilonewtons. In order to transform to kilonewtons, I'm going to just divide by 1,000. And this is going to give me 18.633 kilonewtons over meters cubed. And this is my correct answer. Looking at the options I have, the correct answer is B. So a total mass density of 1,900 kilograms over meter cubed is equal to a unit weight of 18.63 kilonewtons over meter cubed. Next problem. Soil solids have a specific gravity of G equals to 2.71. Find the unit weight of solids in SI units, in kilonewtons over meters cubed. Soil solids. I'm going to go right away and find, let's see, I'm going to do a search for soil solids. There you go. Specific gravity of soil solids. My problem is saying soil solids have a specific gravity of G.271, and we have to find the unit weight of solids. Okay, so I'm given this formula for soil specific gravity of soil solids, GS. Great. And then WS over weight of solids over volume of solids, that is the unit weight of solids. So in here, I can also rewrite this formula. GS is equal to gamma S divided by gamma water. And from here, gamma S is going to be equal to GS multiplied by gamma water. Does that make sense where this came from? So, and this is what we have to calculate based on our problem. Find the unit weight of solids. There you go. Okay, so we can write the unit weight of solids, the formula, or let's start by writing the formula for specific gravity of soil solids. So GS, gonna come back here, because we have GS given in the problem. So I'm gonna start by writing that GS is equal to, we have weight of solids divided by volume of solids, and all this divided by unit weight of water. At the same time, we know that gamma of solids is equal to weight of solids divided by volume of solids. And now if we substitute this formula into this equation, we are going to get that specific gravity is equal to gamma solids divided by unit weight of water. And from this equation, we can calculate unit weight of solids. Gamma S is going to be equal to specific gravity GS multiplied by unit weight of water. And we can just substitute now specific gravity is equal to 2.71, and gamma water, let's write this down, gamma water. We are working with metric units, so we can find gamma water here. Gamma water, this is for US units, and for metric units, we have 9.81 kilonewtons over meters cubed. So going back to our problem, I'm going to write this down, 9.81 kilonewtons over meters cubed. So here we multiplied by 9.81 kilonewtons over meters cubed equals to the result, gamma S equals 2. And always please use your calculators with me. I'm going to have 2.71, 9.81 multiplied. And this gives me a value of 26.58. Let's say 59. 26.59 kilonewton over meters cubed. There you go. And of course, this is approximately 26.6 kilonewtons over meters cubed, which is option A, 26.6 kilonewton over meters cubed. Perfect. Let's move now to the next problem. And this problem is pretty much the same problem as previously, but we have to find the unit weight of solids in English units now. So it's the same problem. We have to work in English units, which is great because at the exam, you're going to have both units. So it's great to get used to this. The same concept as we did before. I'm going to start with GS is equal to, based on the formula found in the FE handbook, weight of solids divided by volume of solids, all this divided by gamma water. And then we know that gamma of solids is equal to this, weight of solids divided by volume of solids. So now if we replace in the above formula, we're going to have that specific gravity is equal to unit weight of solids divided by unit weight of water. And from this equation, we calculate the unit weight of solids equals to specific gravity multiplied by gamma water. And we've got 2.71. The only change in this equation is the gamma water, which it's got to be in English units. And here, in the geotechnical engineering, under the civil engineering, if you go to your civil engineering section, this is the first page that comes up. And on this page, you have gamma water in English units and in metric units. So in English units is 62.4 pounds over cubic feet. So this is the value we're going to use here. Gamma water is 62.4 pounds over cubic feet multiplied by 62.4 pounds over cubic feet. Results. We've got unit weight of solids is equal to, let's see, 2.71, 62.4 multiplied. I get a value of 169.104. 169.104, and this is pounds per cubic feet. And this is our answer. based on these answers or these options, the correct answer is, or the correct option is C, 169.1 pounds over cubic feet. Great. Let's see our last problem for today. A soil mass has a total unit weight of 130 pounds per cubic feet. Find the total unit weight in SE units. So this problem is giving us a unit weight in English units, and we have to find the unit weight in metric units. Let's see how we can do that. There are two ways we can do that. Let's see. I'm going to start by writing down. So gamma is equal to 130 pounds per cubic feet. As I've mentioned before, there are two ways of doing that. We can do the normal way that you would think of doing is transform pounds to kilonewtons and feet, cubic feet into cubic meters. And I am going to do that. And then I'm going to show you an easier way to do that. So let's go ahead and do this transform pounds into kilonewtons. Let's see what this FE handbook offers us. So 1 pound equals to 4.448 newtons. So let's try this. 1 pound equals to 4.448 newtons. So this 1 pound equals to 4.448 newtons. And then let's work on cubic feet. Let's see, feet into meters. Feet into centimeters. It's given, oh, foot into meters. So 1 foot equals to 0.3048 meters. Let's write that down. I'll do 1 foot is equal to 0.3048 meters. And let's not forget, we have to cube this. There you go. Now, in order to bring this to kilonewtons, I have to divide by 1,000. So what I'm going to do, I'm going to say 1 kilonewtons equals to 1,000 newtons. So now I'm going to get rid of newtons and I'm going to be left with kilonewtons. Okay, let's see how this will end up. Very curious about that. Okay, so first I'm going to start by reducing, let me take another color, the units, okay? So I'm going to say, I'm going to get rid of cubic feet. This is it. And then I'm going to get rid of newtons. I'm going to get rid of pounds. There you go. And as you can see, I am left with kilonewtons over meters cubed, which is exactly what I want. Now let's just do the math and see what's the number we're getting. So I'm going to have 130, 4.448 multiplied, enter, I'll have 0.3048 cubed, and then 1,000 multiplied. And now I'm going to have to divide that. There you go. So I'm getting a value of 20.42. 20.42 kilonewtons over meters cubed. It seems that the correct answer is D. So this is one of the ways you can do this problem, or you can solve this problem. Another way, which is a little bit faster, even though this was not that bad, but a little bit faster. Let me show you what is the thought process behind that. Let's go back to blue. Okay. So if I was to take this unit weight of 130, we have pounds over cubic feet. Now think about the unit weight of water. We have unit weight of water in metric units is 9.81 kilonewtons over meters cubed. And we have unit weight of water in English units as 62.4 pounds per cubic feet. And these two values are found in the FE handbook. They're actually, I think, several places in the FE handbook. The place that I look, usually it's under the civil engineering, geotechnical, and they're given here. Unit weight of water in English units and in metric units, 62.4 and 9.81. All right, so now if you think about it, these two, this is SE units, and this is US units, let's say. So if you think about it, unit weight of water in SE units is equal to the unit weight of water in US units, which means that if I come here, I have to get rid of pounds per cubic feet and get a value in kilonewtons over meters cubed. So the way I'm going to do that, remember, if I multiply by a number and divide by the same number, I actually get the same value. I should get the same value. So in this case, if I multiply by unit weight of water in SE units, this is what we're trying to get, SE units, and divide by the unit weight of water, US units, I'm going to get rid of these US units, and I'm going to get a value with metric units. So let's see. 130 multiplied by gamma water, SE, we have 9.81 kilonewtons over meters cubed, divided by gamma water US units, 62.4 pounds cubic feet. This is equal to 1. So I'm not changing anything. And I forgot to put the units for the, this is pounds over cubic feet. So now let's move forward. What's going to happen? I'm going to have pounds here, reduced with pounds here, cubic feet here, with cubic feet here. And all I have to do now is just do the math. So I'll have 9.81, 62.4 divided, 130 multiplied, and I'm getting the same value, which is 20.4, and these are kilonewtons over meters cubed. And is the same value as we got previously by doing it the normal way. That's all I have for you today, my friends. I hope this was helpful. If it was, or if you have any questions, please leave your questions in the comment section below, and I will see you next week.